back with example 1. Find the perimeter and area of this composite figure. So let's talk about strategies. One of the strategies that you could use is identical to what we did on the warm-up activity, and that was to break it up into smaller chunks, each of which is a shape that you could easily find the area of. And we have to do that because this composite figure, even though it's a polygon, right, it has nothing but straight sides here, there isn't a specific area formula for this shape. So we break it up into pieces that we do know the areas for. So for example, I could easily break this up into 2 rectangles and a right triangle that's right there. Another strategy that I could use is I can think of a larger shape, fill in any gaps to create a bigger shape, and then I can trim off the little extra bits that I added in there. For example, I could color in this square here and just look at the figure now. The whole entire figure is now a trapezoid. I can find the area of the trapezoid and then subtract out this red square when I was done. That's not all. For example, maybe I didn't even recognize that this was a trapezoid. Maybe what I do is I complete the whole entire figure and turn it into a rectangle, and then when I'm done, I have 2 subtractions to make. Take off the right triangle that's up here at the top, and take off this square. All right, so just pick one of those methods and solve this to find the specific area, and then we'll come back and we'll find the perimeter of this thing. My favorite method is to turn this thing into the trapezoid, which means that I would just add in an extra little segment right here and pretend like the whole thing is a trapezoid. And I just need, remember the trapezoid area formula is 1/2 the sum of the bases multiplied times the height. The 2 bases are the ones that are parallel to each other. So that's going to be this 18 over here, and then this segment here, which I don't have all of the lengths for. So here's one of the things that always happens with composite figures. You may not have a direct measurement for each of your pieces, and you may have to do some addition, some subtraction, matching some pieces up, just so that you can get some missing links. So if I were to say follow this length straight over here, just to verify it is straight, there we go, it does make a rectangle down here at the bottom, which means that this piece on the right hand side is 18. And if I add it to the 9 that is already there, I get 18 plus 9 is a total of 27. So I have my 2 bases, a 27 and an 18, and my height is always the segment that is at a right angle to both of them. It's perpendicular to both of them. So the area of the whole entire trapezoid would be, so I'll do this as subscript T for trapezoid, is equal to 1/2 the 2 bases, 18 plus 27, and then I multiply it by its height, which is 33. Perhaps I pull up a calculator for this. So I'm going to enter then that 1/2 is a 0.5, parentheses, let's see, we had, I believe, 18 and a 27, and then come out here and then multiply it times 33 of our height. And we have 742.5 exactly. 742.5, and this is in centimeters, so centimeters squared for the area. And then we have to, well, we're not done, remember? Because we just added an extra bit in here that we don't want. We want to take away this shape. And I've been calling it a square, but I need to kind of verify that it is a square. I have that this top segment here is a 10, and by subtraction we were able to get, no, actually just by matching this up with this, we were able to get that this is 18. Now if I subtract off this bottom piece here, 18 minus 8, I can see that this segment that I added in there is 10, making this thing a square. So the area of this square now is 10 squared, side squared. That's 100 centimeters squared. So to get the area of the purple part, the original part that we wanted, I'm going to subtract 100 square centimeters from the 742, and then conclude, maybe I'll write this in white, this is going to be cool. Boop. My area should be equal to exactly 642.5, and then centimeters squared. All right, we're not quite finished with this one because it's also asking us for the perimeter. So the perimeter is just a whole bunch of straight pieces, right? So I've got an 18 here, a 33, an 8, 3 10s, a 9, and then I have a slanted side. So this slanted side is part of a hypotenuse. It is a hypotenuse of the right triangle that is graphed, whatever, right up top here. So I will have to use the Pythagorean theorem in order to find that hypotenuse length, which I will call C. I have one side is 9. How about this one here? How big is that one? Well, it's the same side length as this one down here, which is 33. So I'll use the Pythagorean theorem as AC squared is equal to 33 squared for that bottom side, plus 9 squared for the height of that thing. And then let's just go ahead and use the calculator. So I can, one of the strategies that I definitely suggest is just to do all the math on the paper before you start plugging stuff into the calculator. So for example, I don't want to have to square out 33 by hand. I know that I'm going to put that into the calculator. I don't have to do it right here. I can do it all in one go. So let's say that I had a number here. The last step would be to take the square root of both sides because I want C, not C squared. So C, the length of this slanted side that we're looking for, is equal to the square root of 33 squared plus 9 squared. So I'm just going to throw that into the calculator. Square root 33 squared plus a 9 squared, plus 81 basically. And we see that we have ourselves an irrational number. So one of the things that I could do, instead of leaving it as this decimal number that's right here, I can do 33 squared plus 9 squared, and just say that the number underneath the square root is 1,170. Does that reduce? It probably does. So here my perimeter is going to be equal to all of my straight segments. You know what I'm going to do? I'm just going to pull up the calculator and I'm going to add these all together. So I already have this square root that is up there. So I'm actually going to do the square root of, what was it, 1170 again. Arrow out of that. And then let's add up all of our straight pieces that are here. I have an 18, so plus 18. And then the 33 that's down here in the bottom. We have an 8 and 3 10s, so 30, plus 8 plus 30, plus the 9 that we have over there on the top side. And I think that's probably about it. That's not a 9. And then hit enter. And we get approximately 132.2. And again, notice that these decimals, there's no particular pattern on it. Again, giving us some sort of clue that this is an irrational number. And when I look at that decimal number, it's actually just an approximation. I can just cut it off at one of these decimal places. Let's just choose, say, 0.2. So I'm going to say that the perimeter is, get rid of that equal sign, put an approximately equal 132.2 just plain centimeters, not centimeters squared.